Hi everyone, welcome back to my channel. You are watching Education to All. Today we are discussing Introduction to Trigonometry. So class 10, exercise 8.3. As per the question, express the trigonometric ratios sin A, secant A, tan A in terms of cot A. So let us consider first one, sin A. So given sin A is the reciprocal of cosecant A as we know. So cosecant A. Cosecant and cot we have a relation, cosecant square A minus cot square A, which is equal to 1. If cot square sending opposite side, it will becomes addition. So cosecant square A, which is equal to 1 plus cot square A. So we need only cosecant A. So cosec A, which is equal to square root of 1 plus cot square A. So just replace this in the requirement. So then sin A is equal to 1 by 1 plus cot square A. So then sin in terms of cot we got it. Similarly secant A. Second one, secant A in terms of cot. So what I am doing, secant and tan have a relation. So secant square is equal to, we can write as 1 plus tan square A. Then tan convert in terms of 1 plus tan and cot are reciprocal. So just write tan square as 1 by cot square A. 1 by cot square A. Okay, then this is can be simplified. So cot square A is taken as LCM. So in numerator cot square A plus 1. We need only secant. So therefore it is a square root. Then it will become secant A is equal to, I can write as cot square A plus 1 divided by cot square A and entirely in root. So this can be simplified. So cot square A plus 1 in a numerator, denominator square is there, so it will come it as only cot A outside. And the third one is tan A. So tan A is very simple. Tan A is equal to, we need to write in terms of cot. So tan and cot are reciprocals to each other. So tan is equal to 1 by cot A. So this is a question number 1. Let us move for the question number 2. Write all other trigonometric ratios of angle A in terms of secant A. So what about all this means? First one is sine, and next cos, and next tan A, and secant already we have. So then remaining is cosecant A and cot A. So these all we have to write in terms of secant A. And how we are going to write? First we write the sin A. As per the question, sin A is the first ratio. So I will take it as sin A is equal to, in terms of secant I required. So how I will write in terms of secant? So first convert sin in terms of cos. So we have a rule. So identity 1, sin square A plus cos square A, which is equal to 1. So from this sin alone I have required. So I will take it as sin square A is equal to 1 minus cos square A. Okay. Then from this sin A is equal to square root of 1 minus cos square A. Okay. Then write here the cos in terms of secant. So cos is a reciprocal of secant. So write it 1 minus. So I'll write it cos A is equal to 1 by secant A. So by replacing 1 by cos square. Cos square I am writing as 1 by secant square A in a root. And that can be simplified as taken LCM secant square A in numerator taken as LCM. So secant square A minus 1. Okay, then write here in terms of sine in terms of secant. So therefore square root of secant square A minus 1 divided by secant square A. That can also simplify. So secant square A minus 1 divided by secant A in numerator root and denominator secant A alone. So therefore sin A in terms of secant got it. Next one, cos A. So second one we just taken as second ratio as cos A. So cos A in terms of secant means, so it's very simple, secant and cos are reciprocals to each other. So then cos A is equal to 1 by secant A. Next, third one. So third one we consider as tan A. So third one is considered as tan A. So what is the relation between tan and secant? So there is an identity behind between tan and secant. So by using that we can convert secant square a minus tan square a is equal to 1. So tan sending opposite side and 1 sending to the opposite side. So therefore tan square a is equal to secant square a. We need tan alone, so tan a is equal to secant square a minus 1 in a square root. Therefore the requirement is square root of secant square a minus 1. Next, fourth we consider. So fourth is cot a in terms of secant. Cot is a reciprocal of tan, so I am writing cot is equal to 1 by tan a, and as usually and the before itself we find the tan in terms of secant. So just writing it in denominator. So tan in terms of secant we already found, no? So that I am replacing secant square a minus 1, and then one more cosecant a. So I am taking the fifth ratio is cosecant a. So cosecant in terms of secant. So cosecant is a reciprocal of sine. So I'll write 1 by sin a. Sin a already we did in terms of secant. So sin a in terms of secant is secant square a minus 1 in a numerator, and denominator is secant a. So it's a reciprocal only, na? So in denominator if I write, it will become ulta. So then it will become secant a in denominator square root of secant square a minus 1. So okay, then now all the trigonometric ratios in terms of secant we converted. So let us move for the next question. Question number 3. Choose the correct option, justify your answer. Given number 1, Roman number 1, it's given as 9 into secant square a minus 9 into tan square a. In both the having 9 common, so taking 9 as common, so I'll get it as secant square a minus tan square a. It is an identity, so this value is 1. So 9 into 1, which gives 9. So which option is correct? Option B is absolutely right answer. Next, question number 2. So given 1 plus tan a plus secant a into 1 plus cot a minus cosecant a. So given ratios convert into a sine and cos. So by replacing the given question, so second question is given 1 plus tan writing as sine theta is divided by cos theta, plus secant I am writing as 1 by cos theta is multiplied to 1 plus cot theta. So 1 plus cot I am writing cos theta is divided by sine theta, minus cosecant theta was there, minus 1 by sine theta. So these are reciprocals. Just take LCM in a first term. So cos theta is equal to, so I'll take here is 1. So by multiplying inside, so cos theta plus again sine theta, cos theta cancel, sine theta plus this cos theta again cancel here, 1 alone will come in a numerator is multiplied to. So now in this term sine theta will becomes an LCM. Sine theta here 1, so 1 in sine theta times, so 1 into sine theta plus sine theta cancel, so cos theta in a numerator minus this sine theta cancel, 1 was there. Okay, clear. So now observe the numerator carefully. It is cos theta plus sine theta plus cos theta, both considered as sum a plus plus 1, so that is b consideration, here minus 1, that is b consideration. So it is look like a plus b into a minus b. What it means? So we have an identity, a plus b into a minus b is a plus b, if I write into a minus b, which is gives a square minus b square. Just follow this one, then where a is equal to consider as cos theta plus sin theta, just write it as cos theta plus sin theta whole square minus 1 square, in denominator sin theta into cos theta or cos theta into sin theta. So this is look like a plus b whole square again. So by expanding, so we get it as cos square theta plus sin square theta and plus 2ab, 2 into sin theta into cos theta minus 1, denominator sin theta into cos theta. Clear? So now this is an identity again, cos square theta plus sin square theta is 1. 1 plus 2 into sin theta is multiplied to cos theta minus 1. In denominator again sin theta into cos theta. Got it? Now here minus 1 plus 1 both cancel, and it will become further 2 into sine theta again multiplied to cos theta. In denominator, sine theta is multiplied to cos theta. Got it? And this one, sine theta cancel, cos theta cancel. So what is pending? Still we have a 2 is a pending. So therefore answer is 2. Which option is correct? By checking the options, option C is absolutely the right answer. Third Roman is given secant A plus tan A is multiplied to 1 minus sin A. So that I am converting the given one. Secant we convert as 1 by cos A. So 1 by cos A plus tan we can convert sin A is divided by cos A is multiplied to 1 minus sin A. Okay. Then take LCM as cos A in the first term. So by taking cos A is an LCM. So cos A, here it will get to 1 plus sin A in numerator is multiplied to 1 minus sin A. Again it is looking like A plus B and it is looking like A minus B. So this both multiply again. So we get it as 1 minus sin square A square minus B square. In denominator only cos A. So 1 minus sin square means we have a rule cos square theta. So we have a rule like sin square theta plus cos square theta is equal to 1. So by using that, if I take this value, sin opposite side, so cos square theta is equal to 1 minus sin square theta. Okay, by using this identity, I'll use the value. So in numerator, cos square A I'll write, denominator cos A. Here square and cos A cancel. Square and cos A cancel. So therefore, what is still pending? Cos A. Cos A is which option? So option number D is absolutely right answer. Question number 4. 1 plus tan square A divided by 1 plus cot square A. So convert the numerator as in terms of sine and cos. So 1 plus tan square we can write it as sine square A divided by cos square A. In denominator 1 plus cot square. So cot square convert as cos square A divided by sine square A. Take LCM in numerator separately and denominator separately. So then in numerator cos square A will be the LCM. So then here it is 1. So multiply cos square upside. So cos square A plus sine square A. In denominator what was the LCM? So sine square A. So I'll write it as sine square A. So it is multiply here 1 only na. So then multiply sine square A plus cos square A. So observe very clearly. So it is an identity again sine square A plus cos square A. Here also identity sine square A plus cos square A. That will gives the answer as 1. So 1 by cos square A in denominator 1 by sine square A. This will be reciprocal by writing 1 by cos square A into sine square A divided by 1. So 1 into sine square is sine square. In denominator 1 into cos square is cos square. So then it will becomes sine square A divided by cos square A. So then sine by cos means tan. So I can write this together as tan square A. So on the answer, option D is again correct answer.